Hello, friends. Good day. Let's start our second session with data basics. Welcome to this session on data basics, understanding data types, databases, and spreadsheets, and data formats. In today's digital world, data is everywhere. Every click, every transaction, every message creates information. But truly use data for decision making, business insights, or analytics, we first need to understand the foundations. In this video, I will break down the building blocks of data in the simplest way possible. We will start by exploring data types, structured, unstructured, and semi-structured, and see how each type is stored and used in a real-world applications. From clean tabular data in Excel sheet to messy social media text, each type plays a unique role in analytics. We will look into database and spreadsheets, two essential tools used by everyday professional. You will also learn to use database like SQL and when a spreadsheet like Excel is more effective. We will understand common data formats such as CSV, JSON, and Excel files, formats that every analyst work with daily. By the end of this session, we will have a clear foundation that will help you learn analytics faster and build confidence as you move deeper into the data world. Let's get started. Welcome to Data Demystified Type Storage and Formats, your beginner-friendly guide to understanding the building blocks of the data world. Data is everywhere. Every click, swipe, purchase, and message generates information. But to make sense of it, we first need to understand how data is categorized, stored, and formatted. Let's begin with data types. There are structured data, clean, organized, and stored in rows and columns like Excel or SQL tables. Unstructured data, messy, free-flowing information such as videos, emails, images, and audio. And semi-structured data, a mix of both like JSON or XML, where information has some structure but not a strict table format. Next is data storage. Organizations store data in different places depending on size, speed, and purpose. Small data sets may live in spreadsheets or local files. Larger data sets move into databases, relational or NoSQL. And today, most companies rely on cloud storage platforms like AWS, Azure, or Google Cloud for scalability and security. Finally, let's talk about data formats. You will often see files like CSV, Excel, JSON, or SQL exports. These formats determine how data is saved, shared, and read by different systems. By mastering these basics, you get a strong foundation for analytics, decision making, and future tech skills. Data types are the foundation of how information is stored, organized, and understood in the digital world. Think of data types as labels that tell computers what kind of information they are dealing with, just like we classify objects in real life. At the most basic level, we have structured data. This is clean, organized information arranged in rows and columns, similar to an Excel sheet or a database table. Structured data makes searching and analysis fast and efficient. Examples include customers lists, sales records, and financial reports. We have unstructured data. This type doesn't follow a specific format. It includes emails, social media posts, images, videos, PDFs, and audio files. While unstructured data is rich and abundant, it requires advanced tools like AI to interpret and analyze. The third category is semi-structured data. It sits between structured and unstructured formats. Semi-structured data doesn't use tables, but it still contains tags or markers that makes it partially organized. Examples include JSON files, XML files, and website logs. Common examples like text, names, addresses, and descriptions. For numbers, ages, price, and quantities. Dates, birthdays, deadlines, and timestamps. Boolean, true, false, yes, no. Choose the right data type, ensures accurate handling, proper storage, and meaningful analysis of your information. Understanding data types is our first step towards working confidently with any data system from simple spreadsheets to complex databases. Let's start with common data types. Understand data types is the first step to working confidently with any programming language or database. Let's break down four of the most common and essential data types we use every day. First is integer. Integer are whole numbers without decimals. They can be positive or negative, like number 5 minus 12. We use integers for counting, indexing, quantities, and anything that doesn't require fractions. The next is string. A string represents text. It can be letters, words, sentences, even symbols. For example, hello world, how are you? Strings are used for names, addresses, comments, or any information that appears as text. Then comes Boolean. A Boolean has only two possible values, true or false. It's extremely useful when making decisions in code, like checking if a user is logged in or a user is logged off, if a payment is successful, or if a condition is met. Finally, we have date and time. This date type stores calendar dates and timestamps. For example, today's date, today's time. What is the time now? Date time values help track events, schedule tasks, record transactions, and analyze trends over time. Together, these data types create the foundation for all data handling, analyzing, and programming. Why data type matters. When working with data, one simple choice can make or break everything. The data type. Data types define what kind of information you are storing, whether it's numbers, text, dates, or categories. And here's why they matter. First, data type prevents error. Imagine trying to add text to a number or performing calculations on a date stored as plain text. The system will either fail or give completely wrong results. Correct data types ensure that every operation behaves the way you expect, reducing mistakes and improving data quality. Second, data types optimize storage. Different types use different amounts of spaces. For example, storing a numeric value as text wastes memory and slow down processing. By using the right data type, you make your system faster, lighter, and more efficient, especially important when working with large datasets. Finally, data types enable accurate calculation and analysis. Numeric types allow mathematical operators. Data types allow time-based calculations, and categorical types support grouping and filtering. Without proper data types, meaningful insights simply aren't possible. So always remember, choosing the right data type isn't just a technical detail. It is the foundation of clean, reliable, and powerful data analytics. Database versus spreadsheet. What's the difference? When you are starting your analytics journey, one of the first concepts you will always hear about is database and spreadsheet. While both store data, they are built for very different purposes. A spreadsheet like Excel or Google Sheet is perfect for small to medium sized data. It is easy to use, great for quick calculations, and ideal for personal or team level analysis. Spreadsheets work like digital notebooks, simple, flexible, and visual, but they have limitations. They can slow down with large data sets and prone to manual errors, and don't handle multiple users editing at the same time very well. On the other hand, we have database such as MySQL, SQL Server, or Oracle is designed to store large, complex, and constantly changing data. Database allows many users to work together, keep data consistent, and support powerful queries. They follow strict rules, offer better security, and scale easily as your data grows. So, in simple terms, use spreadsheet for quick analysis and small data. Use database for structured, large-scale, multi-user environment. When to use a spreadsheet, small data sets and simple calculations, quick entry and individual analysis, common use cases. A spreadsheet is the perfect tool when you need a simple, flexible, and a fast way to work with data without building a full database or using advanced software. Use a spreadsheet when your data is small or moderate size, usually a few hundred or few thousand rows. It works best when the data structure is simple, like lists, tables, budgets, or trackers. Spreadsheets are ideal for quick calculations, formula, and visualizations, such as charts or pivot tables. If you analyze sales numbers, tracking monthly expenses, maintaining a task list, or running basic data analysis, a spreadsheet is all you need. You should also use a spreadsheet when your work requires frequent updates, collaboration, or experimenting with different scenarios. Tools like Excel and Google Sheets allow you to edit, share, and explore data instantly, making them great for project planning, financial modeling, and personal productivity. However, spreadsheets are now designed for extremely large data sets or complex relationships. But for day-to-day data tasks, fast insights, and clear reporting, a spreadsheet remains one of the most effective and user-friendly tools you can use. When to use a database, large or complex datasets, multi-user environments, and real-world applications. When working with information, it's important to know when a database is the right tool. You should use a database when your data becomes too large or too complex for spreadsheets. For example, if you are managing thousands of customer records, sales transactions, employee details, or product inventories, a database helps you store and access everything efficiently. Use a database when you need quick search, filtering, and reporting. Databases are built for speed. Whether you want to find a customer by phone number, track monthly sales, or generate a product-wise report, database handle these tasks smoothly. Databases are also essential when multiple people need to access or update data at the same time. Unlike spreadsheets, databases prevent conflicts and keep everything consistent. Choose a database when you need high security, role-based access, regular backups, and reliable data recovery. This is why banks, hospitals, e-commerce sites, and government systems all depend on databases. Finally, use a database when your data connects to other systems like apps, dashboards, websites, or automation tools. Common data formats you will encounter: CSV, JSON, XML, Excel. When you start working with data, you quickly realize that information comes in different shapes and structures. Three of the most common formats you will encounter are CSV, JSON, and XML. Each plays a unique role in how data is stored, shared, and processed. Let's start with CSV, our common separated values. This is the simplest and most widely used format. Think of it as spreadsheet, save in plain text, that is comma separated values. Each line presents rows and comma separate the columns. CSV files are lightweight, easy to open in Excel, and perfect for large tabular datasets. Next, we have JSON, which stands for JavaScript Object Notation. JSON is modern, flexible, and designed for structured data. It stores information in key value pairs, making it readable for both humans and machines. JSON is heavily used in API and web applications because it handles nested data extremely well. Finally, there's XML or Extensible Markup Language. XML uses tags to define data similar to HTML. It's highly structured and supports complex hierarchies, while XML is older and more verbose than JSON. It's still common in banking, finance, and enterprise systems due to its strict formatting. Understanding these formats is essential because the better you know your data, the faster you can analyze, transform, and make decisions from it. Why data formats matter? When we work with data, the format we choose can make or break how easily that data is shared, understood, or analyzed. That is why understanding data formats truly matters. First, universal sharing. A good data format allows information to move smoothly across tools, teams, and systems. For example, a CSV file can be opened by Excel, Google Sheets, Python, or almost any analytical platform. Choosing universally accepted formats removes barriers and keep workflow fast and efficient. Next, readability and balance. Some formats like JSON are structured in a way that's both machine friendly and still readable for humans. Others like Excel offer visual clarity but not be ideal for automation. The key is to balance human readability with machine compatibility depending on the task at hand. Finally, using the right tool for the job. No single file format fits every scenario. CSV is perfect for clean tabular data. JSON works best for web data or hierarchical information. Excel is great when you need formula or quick visual insights. Picking the right format ensures accuracy, reduces errors, and saves time during analysis. In short, data formats matter because the right choice leads to smoother sharing, better clarity, and smarter analytical decisions. As we come to the end of the session, let's take a moment to recap your first steps into the world of data. Every successful data professional starts with one simple foundation: understanding data itself. And today, you have taken that important first step. You learned the data structure is clean, organized, and fits perfectly into tables. Unstructured data is messy but rich, like videos, emails, and messages. Semi-structured data gives you the flexibility of both worlds. When you know your data types, you instantly know how to handle, store, and analyze information more effectively. You also explored how to choose the right tools, from spreadsheets like Excel or quick analysis to SQL for handling large data sets, to visualizations tools like Power BI and Tableau that bring data to life. Remember, the best tool is the one that makes your work faster, clearer, and more accurate. And finally, understanding data formats such as CSV, JSON, and Excel helps you work smoothly across systems and collaborate with confidence. So, as you move ahead, know this: your data journey has officially begun. Keep learning, keep practicing, and stay curious. The future belongs to those who can transform data into decisions. All the best, and see you in the next lesson. Good day.